Good morning. Purnima, good morning. Manasi, good morning. Yuga, good morning. Achal, good morning. Anuja, good morning. Mitali, Nikita, Bini, good morning to you all. Praveen, good morning. Anjali, Kumari, Kriti Patil, good morning. Kirti Patil, not Kirti, Kriti, sorry. Ritesh, good morning. I see this name for the first time, I suppose. Suyog, good morning. Viraj, good morning. Durvesh, good morning. Swarada Joshi, good morning. Vikrant, good morning. Ishwari Ranadive, good morning. Sarthak Mahajan, good morning. Tejas, good morning. Gautam, good morning. Devrishi, good morning. Beautiful name, Devrishi. Devashri, Devrishi, I'm not able to. Avinash, good morning. Prajwali, good morning as well. Well, last time we've finished with Wagner. Finished with Wagner in the sense, finished with his theory. Wagner is immortal. Harshal, good morning. And nobody can finish him that easily, isn't it? Jokes apart, today we Akshay, good morning. Prachi, good morning. Om, good morning. Today is a very special day. Yeah, Akshata reminds me of the very thing that I was supposed to be saying. And yes, I have a special slide prepared for you for this particular occasion. Sir, today is great conjugation of Saturn and Jupiter. Can you give geographic aspect about it? Oh my God, you have put me into a fix. I don't know whether I have any geographical aspect of it. Just spare me a couple of seconds before I come back, because I'm a bit uncomfortable with the specs that I'm wearing. I was carrying the other one the other day. If I get hold of it quickly, I'll come back to that. If not, I will have to carry on with that. Oh my God, I am not able to trace it anywhere around me right now. So possibly we will have to continue with what I'm wearing right now. Not that it makes much of a difference, but you see that I keep on watching like this because these are bifocal lenses. Chinmay, good morning. Pragati, good morning. And being bifocal, I need to do this when I'm reading something, and then I need to do this when I'm speaking to someone as such. That the other pair of specs was basically completely a positive one, in the sense it was only for reading, and thus was more comfortable. Anyway, we'll go ahead with that. As I said, Wagner we have done, and all the way to the criticisms of how Wagner was very severely criticized as far as this theory was concerned. And the very fact that in spite of the criticisms, his theme, his idea was so genuine that it is being used even today as a part of explaining crustal formation as such. Sheetal, good morning. And it's not only Wagner himself who reminds us of regular things, but please be reminded that all the other theories are actually following Wagner as such. Okay? It's the seed that Wagner has sown, and eventually scientists are reaping out of it. Okay? Not that again nobody otherwise would have, but obviously someone doing it for the first time is always remains to be doing it for the first time as such. I'll do one thing. We need to go into, sorry. Just give me a couple of more moments so that I come back to, yeah. I'll start sharing the screen, and we'll discuss both the episodes that are happening today. And This is the one. I don't know how many of y'all are still following weather and radar, but on the screen right now, okay, I have 4 places in different parts of the world. These two, that's Halley Research Station and Cape Horn, both of them are in the southern hemisphere, and Tromso and Norway Urengoy. Okay, I think you must have I may have spoken about these towns earlier also. When I think we met on the 23rd of September or around that period, I was referring to the solstice, or sorry, equinox, and today is the winter solstice. That's winter solstice basically means the longest day in the southern hemisphere and the shortest day in the northern hemisphere as such. As far as the Halley Research Station is concerned, it's basically a British research station on the continent of Antarctica. So, Antarctica, most of the continent being beyond 66.5 degrees, is presently experiencing polar day. Polar day basically means that you're going to have 24 hours of sunlight. There are a few more things that we can just look into these aspects. That means the actual temperature is -7 degrees, but it is feeling like -11 degrees as such. Let me tell you that more drier the air, the more say chiller the feeling would be. Okay, I'll come back to this when we take up at some other point of time. We take up temperatures of in fact, I have the Indian cities also. So let us see if we can find something. Basically, because we may not find it in Indian cities, provided for the fact that we have winter in the northern hemisphere. But let us see. When the weather is dry, I would say it will give you a more chiller feeling as such. Along with that, you'll see that winds are blowing at a speed of 10 kilometers per hour. You'll see that again when the wind picks up, this number, if this had been 30, this number would have been further low by a couple of degrees as such. So these are a few geographical things that we need to keep in mind as such. And this is Cape Horn. Cape Horn is again, you'll see that it is feeling chiller. Okay, of course, because it's night time there, because it should when I click these screenshots in the morning today, it was still Sunday in Cape Horn. Cape Horn, of course, is say the southern tip of the continent of southern America as such. So though the temperature is 6 degrees above 0 degrees, you'll see that it feels 1 degree because of the night. Winds are much fast, you can see here, as compared to winds here. Okay, you have very severe wind. Now, this could be because of the fact that it's the tip, and of course, on the either side, you're going to have oceans. One side, you're going to have the Atlantic Ocean. The other side, you're going to have the Pacific Ocean. Interestingly, you'll see that this is the southern hemisphere. The sun is rising much early. That's 4:45 in the morning, nearly 4:45 in the morning, and is setting as late as 10:16. Okay, 10 hours, and 22 means 10 hours in the night as such. So you are presently having a night of what? Not more than 6 hours as far as the southern hemisphere, this place is concerned. But on the contrary, you come to Tromso. Now, why have I chosen this? Because you'll see here the difference is much less. Okay, 4 degrees is the actual temperature, and feels like 2 degrees in spite of being a polar night, is because you'll see that in the background you have a lot of clouds. So you'll see that water plays a very important, being students of science, you need to remember this, that water plays a very important role in stabilizing conditions. Okay, and that is why you'll see that say for example for India, when our summer starts somewhere in March and it ends somewhere in September, the temperature should be varying all the time, but you'll see that March, April, and May, the daily variation is huge. But the moment you have the monsoon setting in, you'll see that the lower temperatures and the higher temperatures, both of them hover around a very general mean around them. Okay, that's basically because water vapor tends to absorb a lot of heat, and that's why you'll see that the lower temperatures don't drop much. On the other hand, water has its own temperature, so it will not allow temperatures to rise above a particular level. Okay, so that's the controlling use or factor of water, you can say. Okay, Tromso is one of the northernmost location I could identify as far as latitude wise is concerned. Um, this is in one of the Scandinavian countries. I would like to remind you. You can search for it as well. But interesting thing, you have winds blowing here as well, and temperate regions normally you'll have comparatively stronger winds. I won't say 10 kilometers is very strong as such, but when we are going to come to the Indian slides, I will remind you of that. Uh, the temperature between the actual and the feeling like is not much of a difference, but the difference is much more here. Nove Urengoy is basically a continental location. It's surrounded by land on all the sides, and you see that say as far as land is concerned, because of its specific heat being so very unique. Okay, land heats faster and cools faster. Similarly, waters, because you have water tends to be transparent and heat passes through the layers of water, which doesn't happen as far as land is concerned. Um, Ocean waters, they do heat slowly, and of course they cool slowly also as such. But this is I would say that if you need to hunt for this particular place, the only thing you have to do is go absolutely north of India. Okay, you go from here all the way to Jammu Kashmir, and you keep traveling northwards all the way up, and then somewhere in Siberia you're going to find this particular place. In fact, I think it's exactly around 66 degrees, if I'm not wrong. But why is it that we don't have it as a polar day or night is a different issue. We'll speak about that when we are doing the second topic, second paper in the second semester, first paper in the second semester, when we'll be speaking about climatology intensively. Interestingly, you'll see that the difference between the actual temperature and feeling like is much. Okay, I would say it's among the highest as far as the four places is concerned. Okay, you'll see that 17 degrees is the difference. While the temperatures already are low, you will see that the actual feeling is like minus 57. I don't know how people would be living in these areas. Such the sun rises here at 10:30, and it is setting down at around 1 o'clock. So you'll see that this is we'll be tracking this particular place for a couple of few days to come down, and I will be posting this again and again. Let us see that in spite of the Earth having attained winter solstice position, is there any further change into the negative as far as Novi Urengoy is concerned as such? So 10:30, 11:30, 12:30, and not even 3 hours of daytime as such. Okay, you'll see. So it's more than 20 hours of night, and that is what also keeps these temperatures very low as such. Okay, so that is one. Then with Indian sense, if you remember, I've said this earlier also that these are the four corners I could locate as far as India is concerned. The northern corner, you'll see that the wind, in spite of it being in the hilly region, Gilgit, okay, and you'll see that the temperature is 5, though it is low, it feels like 5. We are in the tropical region, remember now. As such, the sun is rising at around 7 o'clock in the morning, and it is setting down at around 5 o'clock. Okay, so the day is reduced by 2 hours on either side of the mean wind speed, because there is not much variation here. Okay, you'll see that the wind speeds are low as such. 5 kilometers is not much. You hardly have a wind here. Once again, you'll see that while it is the same here, it is the same here as well. Along the easternmost location I could find on the Indian map to represent on the slide as such. 17 degrees, feeling like 17 degrees. This right now was around 7:30 in the morning today. Sun is rising much ahead, okay, of this. You'll see that it rose here at 7 o'clock. It's 5:45 in the morning here, and it is going to set early, okay, because of its eastern location. Not to do with the latitude, it is more to do with the longitudinal location of this particular place, okay. And because it's into the Himalayas, eastern parts, the AQI is just 20. You watched the AQI for other places, if they have shown here, we'll see that it would be anytime higher than along as such. Okay, Dwarka. Okay, AQI, just to compare, is already higher than Dwarka is the westernmost corner. Temperatures 20, feels like 20. All these places have a tropical location, so there's not much variation. The sun is rising at 7 o'clock, 7:30, and it is going down at 6 o'clock in the evening, as in contrast to this place and as in contrast to this place as such. And then Kanyakumari is not showing you AQI, but wind speeds are there. Again, very low wind speeds as such, okay, because of the location. Temperatures, sun is rising at around 6:28 here. That's much late, and then it's setting at around 6 o'clock. So the nearer you are towards the south, you'll see that lesser the variation as far as the rising and the setting of the sun is concerned. The rise is 28 minutes and the set is 7 minutes beyond 6 o'clock. So as compared to these places here up, in fact, this place here, you'll see that the variations are much less when we are speaking about Kanyakumari, is how these people spell it. So this was 4 different places in different parts of the world, and these are 4 places, 4 corners, I would rather say, as far as Indian corners are concerned: north, east, south, west, and south. Okay. Yeah. Somebody did remind me of the conjunction, and that's going to be, it's much discussed celestial feature, I would say, which is being discussed for quite some time now. We are in a very say fortunate era that such things, unique things, are being discussed. You'll see that 50 years down the ago, we did not discuss this. Of course, technology, along with technology, I would say we should thank Google, we should thank Wikipedia, that we have a lot of information. We should thank the media, which keeps us informing and updated about all these things. You'll see that people, this diagram down here first is actually when they started noting this one right away in the from the 2nd of October, okay, when they were much away from each other, and day by day they have split it into 4 days period as such, 2, 7, 12, and you'll see that by the end of October the space had narrowed down. By the end of November it has further come down, and you'll see that 21st December. Now, interestingly, you'll see that when I was looking at this from a distance as such, I did not get the feel. But when I'm looking at it from nearby, okay, what do you get a feel of those lines? Do you get a feel of the curvature of the path of the Jupiter? Do you get the feel of the curvature of Saturn? You'll see that if you look at it closely and keep watching at it, you'll see that it looks more spiral, isn't it? It's not straight lines, it's spiral. That's basically because of the fact that Saturn is much away from the sun as compared to Jupiter, and again, as compared to Saturn, the speed at which Jupiter revolves around the sun, though it runs into years, it is much faster. Okay, so what has been happening is that if this is Saturn and this is Jupiter, okay, it has been catching up from, let us say, October. It has keep catching on, and you'll see that tomorrow it will go beyond. Okay, and say in another month's time, you'll get a perfect hourglass shape for that particular spiral lines as such. Okay, so these are, I frankly speaking, I was not aware of this shape taking that particular form as such. It was only when I expanded it for our vision, or our view, I would rather say, that I got a feeling that yes, there is a 3-dimension to this. And if, as I said, 3-dimension is not something that you see. 3 dimension is something that you need to tell your brains as such, that look into the 3 dimension aspect in front of you. And the moment you look at the 3 dimension, it should be, it takes some time to calculate in your mind, and it starts giving you that particular feeling as such. So that is how it is. It has been looking for some time, and today, it's going to look very wonderful. Okay, that they are going to be in absolute conjugation with each other. What is conjugation? Okay, you'll see that conjugations tend to happen every 20 years. But why is this so special? The last one happened in 2000. But these conjugations aren't at all created equally. The 2020 great conjugation of Jupiter is Jupiter and Saturn will be the closest since 1623, and the closest observable till 2026. Okay, so the fact that it happens every 20 years is not a big deal. That it is happening in a very interesting way is a big deal, and you'll see that the closest observable, okay, since 800 years, that's something, that's a celestial phenomena, I would rather say. And again, as I said, we should be considering ourselves lucky that we are a witness to these. There are so many phenomena that are happening around us that we should be considering ourselves lucky. As students of science, we should be able to enjoy this, and we should be able to understand this as well. Okay, but while single conjugations of Jupiter and Saturn occur every 20 years, such triple conjugations are far less frequent, occurring about once every 180 years on an average. The last time it happened was in 1981. The next one is going to happen in 2239. I believe none of us is going to be alive by that particular time, however long any one of us amongst us would live as such. Well, coming to the business end of what we are supposed to be doing, as I said, that we have finished with, so to say, the Wegener's theory of continental drift, and we need to move ahead of that. Now, while we move ahead, I again remind you that, in fact, when we went into the Wegener's theory, we actually came back into reverse from the plate tectonics, and I did bring about a few slides on the plate tectonics then also. And today, as I said, we are going to progress chronologically from Wegener onwards into plate tectonics. As such, I did tell you that you have the theory of convectional current, and then you have the theory of seafloor spreading, which is a fallout of the convectional current. So one after the other, things are leading to plate tectonics, which took its actual format somewhere around 1960. Okay, you'll see that the formation, the picture that you see on your screens is those mountains. Okay, earth materials, plate tectonics. Okay, why have all the mountains not worn away by now? Okay, as I said, that when I was explaining the real essence of geomorphology, that endogenic processes are continuously creating crust, and exogenic processes are continuously, I would say, destroying the crust as such, but they are polishing the crust as such. Destruction would be a very harsh word that I would be using for these processes, because of the beautiful landforms that endogenic processes tend to give us. Okay, so I would say they polish up as such. So it's a continuous process. That's what we mean to say. Both, it's so very dynamic, endogenic as well as exogenic as such. Okay, the Earth structure, it's of course divided into various layers towards the center of the Earth. I don't know whether we have, but if we have not discussed, the radius of the Earth is somewhere around 6,400 kilometers, and this is how the layers look. I think we have done this diagram earlier also. The crust is thin, the mantle extends almost halfway to the center. So I would say that share-wise, you'll see that 50% is mantle and crust, and of course the rest of the 50% is core, which is further divided into outer core, which is liquid, and the inner core, which is a solid. The core makes up the rest. We have seen the composition. We have seen it's continental crust and oceanic crust, and then you have upper mantle and so on and so forth. Low density solid crust floating on an almost solid mantle. Almost solid mantle is an important word here, but overall the Earth is dense. Okay, the core must be very dense, obviously because of the pressure and the material that makes it up, and which happens to be nickel and iron as hot liquid outer core and solid inner core is what makes up the composition of the interior of the earth. Uh, what do these processes lead to? Okay, the endogenic forces which make the crust and all this is something that we study as a rock cycle into geomorphology as such. What exactly do we mean by the rock cycle? You see that weathering breaks down the rocks and erosion wears them into smaller pieces as they are transported towards the sea. Okay, you see that if we are to gradually move from one to the other, you'll see that volcanic activity, this is molten. Okay, you have a lot of heat and pressure which is going to push this up, and you're going to have this molten lava that is going to come out. Okay, this is going to be called as lava, and this is the magma. Remember, we did discuss this at some earlier lecture that before it comes in contact with the air, you're going to call it magma. Once it comes in touch on contact with the air, you start calling it as lava. Okay, it's going to weather away. It is going to erode away. That's going to be transported. This transportation is going to make it settle down somewhere, and this settling is going to lead to sedimentary rock formation. Okay, so that's the sedimentary rock of it. You'll see that on the crust or beneath the crust, the pressure is going to transform the igneous as well as sedimentary rocks. Okay, they are going to be physically transformed into metamorphic rocks. It leads to a complete restructuring, and new forms of rocks do emerge out of them as such. So this is a part of what we are supposed to be. Say, as I said, when I speak about plate tectonics, it's at a very small scale. Okay, but when I start speak the same thing, when I start speaking in the terms of a rock cycle, you'll see that it is a large scale diagram as such. Scaling is very important, let me tell you, as far as understanding geomorphology, or on the as a matter of fact, geography is concerned as such. Now, these deposition of these sediments, most of the sediments settle down in water. Okay, and you'll see that once they settle down, okay, you'll see, you must have seen this, those of who have been to the beaches as such, you normally see these ripple marks that happen. Now this is typical river, so this is going to be much sticky and clayey as compared to that. Currents and waves form ripple marks on the surfaces of these. As such, evidences can be found from this in the rock as such. Okay, so many a times when this is going to dry up and form a rock, you could find them on the present day rocks also. Okay, that will remind you of what was the time that they went into formation. Ripple marks can be preserved on the rocks, and that is why they can be seen around us today. As far as sedimentary rocks are concerned, the movie that we were referring to, and we saw it in home also, the Grand Canyon. You see that these horizontal layers are nothing but having the youngest rocks at the top, and of course the older rocks towards the down. Rocks and fossils get older as one goes down as such. Okay, what does this mean? That means that the earth is unstable, and the earth's crust is subject to huge forces. Okay, very large forces can fracture the rocks as such. Okay, you'll see that this is one example of how faulting is one example of these fractures being created, and they can be seen as fault lines, literal fault lines on the rock layers as such. Okay, while this is a diagrammatic representation, you can see here this is a picturesque representation. You need an eye of a geographer or a geologist, I would say, to identify these faults in the field. Normally, they are not visible to the layman if one is not trained into identifying folds and rocks. They will just identify the aesthetic sense of it. Aesthetic sense is more there in sedimentary rocks more than in faulting as such. Tilts and folds will include sedimentary rocks often get tilted, and this is how they would look, and then they can also be folded by huge forces. Okay, this has happened at the Lulworth Cove. Okay, this is of course some place somewhere, most probably in the US. Sometimes the rock layers can even be turned upside down. As let us see if we can find anything here. Okay, you'll see that here. Okay, this is the unconformity. This is an unconformity. This is all the time, all the space through which I'm moving this cursor like hand, you'll see that here again you'll see the unconformity. It's along these margins that the rocks have been moving. Okay, this curve. It's along these margins that the curves have been moving as such. And then you'll see that here, okay, they are overturned as well. Okay, this again here is, and this is a huge thing. Okay, if you are not realized by now, let me tell you that these two dots that you see on the top, these are human beings standing up at the top as such. So this is huge folding as such, just like the Himalayas. Himalayas, of course, are going to be much more than this, but this is how it would look otherwise as such. And then, yes, you'll see that this is one of the most famous of the pictures of Wegener, and that is why you find in all these PPTs as such. Okay, and you'll see that it's more or less the same thing, but they have added one more here, that he died before people actually accepted his ideas. As I said, he was heavily criticized the moment his work came to be translated into English. And it's 1926 when he lost his life, lost his way, and eventually lost his life in a cyclone, or I would say a temperate cyclone as such, or a blizzard, you could call it as such. And that is how we slowly move to plate tectonics. Okay. The yellow line basically shows you the margins of the plates as such. What are the evidences? The same fossils and rocks found in different parts in the world. Africa and South America look like pieces of a jigsaw. It's all they, you remember they're speaking about Wegener. And then you'll see that when you have earthquakes, when do we have earthquakes? Plates moving in any direction can cause earthquakes. The worst are caused by plates rubbing past each other. Okay, basically because it's when they create a lot of hustle bustle when they pass against each other, rather than when they are moving from each other, or they're moving away from each other, or moving into each other as such. Okay, you'll see that one thing is the San Andreas Fault, which is in California, Californian coast as such. This is how it looks from the top. Okay, and then, as I said, we come to seafloor spreading. Okay, you'll see that it is believed that while once upon a time it was believed that land was very dynamic, and because of the volcanoes, etc., that land would be very fresh as compared to the ocean floors. It was in fact later realized that it was not land, but the seafloor spreading theory brought to forth that it was actually the sea floors which were very fresh as compared to land as such. And if we go trace by trace into these one by one, you'll see that let us assume that this continental crust is North America and this continental crust is Europe, some hundreds of millions years ago. And there was upwarping here, okay, because this mantle here was pushing everything up. This plume in the mantle was pushing everything up as such, and suddenly it ruptured. Okay, and while it ruptured, it started pushing these plates apart from each other, and you had a linear sea as water accumulated, because this was comparatively a low level, and the water accumulated in this, and these plates kept on going away from each other, and you have the formation of if you're going by the same example we have taken, with the formation of the Atlantic Ocean, with Europe and America, Europe on the right side, America on the left side, being separated by what is called as the mid-oceanic ridge as such. Now, an obvious question, why don't you find these ridges here? There could be many reasons for that. If you would ask me, sir, why does it happen that way? The reasons could be that these volcanic eruptions are very fast today. That's why they are creating one after the other ridges as such. Second, what has gone away from it? Okay, you can observe this by practical observation also, that the ridges which are nearer to this divide are going to be taller as compared to as you move away from it. Basically, because the water is going to polish off the crests, and it's going to erode it off as well. So as you go away from it, the height will decrease. So erosion, weathering will lead to dismantling of the actual size of the ridges as such. Okay, so that's how these things tend to happen as such. Just a moment. Sorry for that. Large continents begin to crack up and split apart. Okay, and these gaps fill with water. Small seas become oceans, and mid-oceanic ridges continue to produce new crusts. Okay, now if you can imagine the African continent, and if you have heard about the Rift Valley, if you have not, you can check it now. Now, in the sense, after the lecture, at any point of time, you are free. You can check where the Rift Valley is, and in fact, as far as plate tectonics is concerned, this is what it is being say putting forth as such, that the possibly the African continent now is going to break further. Okay, and you would have the continent, the African continent being split from. If I have the let me see if I have any world map with me. If I have the world map, I'll just tell you. Yeah. Um, if you can see the cursor, okay, you can below the cursor. I'm in fact tracing a line which takes you through the Rift Valley of Africa. Okay, so it is believed that this is going to separate, and this piece of land will be separating itself from the African continent, and African continent is going to be smaller as compared to what it is today. Of course, it is not that easy to happen. This would take a few thousands of years, at least, if not millions, for that to happen in some point of time, at some point of time as such. Why do we have the spread? Okay, that's basic. If you see the mid-oceanic or mid-Atlantic ridge as such, you'll see that this S shape is the ridge. The whole Atlantic Ocean in itself is S-shaped. Okay. Now, why it is an S and why it is not W is something that remains to be studied as such. But you'll see that towards the center of it, okay, that means that it is spreading at an equal pace on either side. I did mention it earlier also that the Pacific does not do so. So you have a very weird geometry as far as the Pacific plate is concerned, but you have a very geometric shape when it comes to the Atlantic Ocean. Okay, you'll see almost same on either side. That's one thing. Secondly, you'll see that it's Iceland where this ridge comes above water. Otherwise, the ridges or beneath the oceanic waters, and it is separating along this particular ridge, or this is in the length. It's widening, let us say, along this particular ridge as such. Why is the Atlantic still getting wider? The plates are being pulled apart by convectional currents in the mantle below. Okay, it's not only obviously the volcanic eruptions that are pushing it, it's also the convection that is putting. Now, what is this convection all about? Okay, this is actually the heat which is released during the type of natural radioactive processes that tend to take place deep down in the mantle. This heat, because of convection, wants to come up, and you'll see that it starts coming up, and along with it, the heat is so huge, the energy is huge, and that's why you'll see that it brings everything along with it. And the hotter ones are going to upwell, and you'll see once they come to the surface, they're going to move in a clockwise way towards the right hand side and anti-clockwise way in the left hand side. Once it gets cooler, of course, it's going to go deeper, and then the same cycle happens. This cycle could take a few 100 million years as such, upwelling and downgoing, upwelling and downgoing as such. This is a continuous process that keeps on happening as such. At the mid-Atlantic ridge, molten rock from below rises up to fill the gap between with new basaltic rock. Now, why basaltic rock? Remember, the pressure of the water will make it cause as basaltic rock. And because it is basaltic, it stays down, it stays dense. And when you have, say, clashing of plates as such, the denser material is going to go down as such. And that's why continents which are more granitic tend to be as they are, in spite of the fact that they are, say, a few billion years old. Okay, let me tell you that no ocean crust, it has been proved by scientific data that no oceanic crust is more than 180 million years old. So average oldest, okay, you're going to have is 200 million years old, while land pieces are a few billion years of old. Remember, 1,000 million make a billion. Okay, so you can just imagine how fresh the oceanic crust is when you compare it to the say the land masses, say for example, peninsular part of India as such. Okay, what more evidence do we have? Okay, more evidence has been found in the Wegener's theory. The Earth's north and south poles have flipped many times. And if you remember, I spoke about paleomagnetism coming to the support of Wegener. This comes much late. Okay, you'll see that period of normal magnetism, and then you have reverse magnetism. They are showing it on a much larger scale. Okay, you'll see that you're going to have alternate bands when the magnetic poles of the earth were reversing and normal and reverse and normal. So you have alternate bands of these rocks, which prove that the oceanic crust is dynamic. One thing. Secondly, that the earth is shifting its magnetic orientation and inclination regularly as such. And as I said, that these leaves magnetic strips in the rocks which contain iron minerals as such. Okay, so the earth must be growing. Yes, does the earth grow in that way? We have already seen the answer to this, that it will not happen so, because of the fact that the denser of the material is obviously going to be overridden by the lighter of the material. And you'll see that the same material which is going to melt down into magma and come up as lava, now when it comes in on land, it may transform itself into granite. So that's a very interesting development we should be having. Oh, the moment I went into enlargement, it has stopped. Okay? So while it goes down, the pressure is going to melt this plate here and this melted plate on when it comes up on land. It's not that always it should come on land as such, but more often than normal does it come on land. Okay, and you're going to have volcanic mountains and volcanic chains of lava as such. Okay, dense, heavy oceanic crust can be subducted below less dense continental crusts as such. The friction melts the rock, the magma rises through the crust to form new volcanic. And this has been happening in South America, the Andes. Yes, a major part of the Andes is, for your information, folds, but in some areas, okay, you'll see that you have volcanic eruptions, and that is why, if you remember, I said this in an earlier lecture that some of the severest of earthquakes are happening along this particular margin as such. So that's why the earth does not grow in spite of the fact that it keeps on spewing up a lot of lava and formation of crust as such, because while at some point of time or at some place it's forming, it's at some other place it's destroying itself also, and that's why it keeps the balance as such. Do continents collide? Yes, continents do collide. The best example very near to us is obviously the Indian Ocean, Indian Peninsula. You'll see that this the Indian Ocean ridge, it's splitting along this particular hotspot here, and that makes the Indian plate move towards the Eurasian plate. And when it collides with the Eurasian plate, okay, some part of it is going down, while the Sea of Tethys, this you could be called as the Sea of Tethys. Of course, it's not that. It extends all the way towards the Mediterranean also, is what people believe. And the Sea of Tethys here is closing into the formation of the Himalayas. That reminds me that I spoke about the Mediterranean also, that it's believed that the African continent is closing towards the European continent, just like the Indian Peninsula did so as far as uh, millions of years ago, at least 60 million years ago, and went into the formation of the Himalayas. The very fact that you have active volcanoes in Italy and all around that place means that it's an active place, and the African plate would close into the European plate, and all the sediment that lies in the present Mediterranean Ocean would at some point of time be folded up into a mountain, and scientists believe that that mountain could be taller than the Himalayan mountain range. Whether this happens, nobody knows. This is an hypothetical thing placed on some scientific facts. So yes, we have to believe that this should be a possibility, but you don't know that the interior forces, how they would operate, and whether it actually presents in science do show that yes, the African continent will close the Mediterranean gap, and the Mediterranean Sea will rise up as a fold mountain as such. Okay. Um as I said, the heat and the pressure will make metamorphic rocks. It also pushes and folds the rocks above into high mountains. The Himalayan rise to 8848. Obviously, this now needs to be corrected, are still growing as of today. This is as far as, in short, the plate tectonic theory was concerned. The actual, I would say, the academic part of it. You have a lot of these PowerPoints of different. As I said, I've borrowed this from the net. This was donated to the worldofteaching.com. Okay, and you can go to this particular site, and you'll have numerous ones and thousands of PowerPoint submitted by teachers, okay, on this particular thing. Now, I have donated my PowerPoint presentations to slideshare.com. This is one another similar one. Well, of course, this is not as philanthropic as this is as such. What do you have for me? Sheetal, Saurabh, Nipanikar, good morning, sir. Yuga says, sir, could you please share this PPT on the group? Yes, definitely. I'm going to share this on the group. Yeah, I can understand that these pictures are not that clear. On a mobile screen, yes, they tend to get very blurred at times as such. Well, as I said, and I remember that as far as the um, theory of plate tectonics is concerned, if I remember right, it is a scientist named by Hugo, Hugo. He was, I think, from the Columbia University. I'm not very sure about that. He has used the term plate for the first time. And they had to correct this basically because they knew that what Wegener had said was something similar, but it did not have that much amount of scientific base. Okay, and by now they had realized that this was happening not in the Sial and Saima, but it was much deeper seated. So they had to include all of that to form what was to be called as the lithospheric plate. Okay, while Wegener believed that say a few 50 tens of kilometers of Sial is floating in a few tens of kilometers of Saima, totaling up to only 50 kilometers. These people believed, who advocated the plate tectonic theory, that it is actually not 40, 50 kilometers thick, but this whole process happens in a plate which is 100 kilometers thick as such. The rest of the 50 kilometers is made up of the upper layers of the mantle. And the upper layer of the mantle is not an absolute solid, as they said. In fact, it's not even a liquid as such. It's basically a pasty thing. And that's why the convectional currents do occur. And what keeps it in a pasty way, you'll see that it's the energy released by the radioactive material which is there. Whether it is there in the other parts, don't know. But yes, it's there as far as the asthenosphere. That's the upper 50 kilometers of the. It's not exactly 50, but for our purpose, let us say it's 50 because the upper 50 and this 50 is going to accumulate to a thickness of 100 kilometers. So it is believed that every plate is approximately 100 kilometers thick. If it's going to be an oceanic plate, it's going to be a bit thinner by a few kilometers as such. But as far as continental plates are concerned, they are going to be much thicker because it includes the land surfaces in that as such. As we saw in the play slide or the presentation, as it's the convectional current that move in cyclic format, and they push up the material. Okay, in this, that leads to two types of the first type of movement, and that is divergence. These are called as divergent margins. All the ridges that we saw are nothing but divergent margins as such. But the fact that if crust is being created and at the same time the earth is not increasing in size as such, means that while at one point it is going to be moving away and creating crust, this very crust needs to be destroyed at some other place to keep the size of the Earth going, isn't it? So while it is diverging, the plates are diverging at some particular point. These plates could be converging at some particular at other locations also. These are called as convergent margins, or these are called as destructive margins. And as far as the diverging margins are also called as constructive margins as such. So there we saw that science takes its place, and the denser material is going to go down and the lighter material is going to override. If you have sediments in between them, they could rise up into fold mountains, which we see as a part of the Rockies of North America and the Andes of the South America. The Pacific plate is going down, and the North and the South American continents are seen to be pushing themselves towards the west. So that's as far as the convergent margins is or are concerned. And the third type of margin, which is neither divergent, neither convergent. Okay, they're not moving away from each other, they're not moving into each other. They are moving, sliding past each other, and we have already noted that these are more dangerous because they cause a lot of earthquake activities as such. So that in short is the plate tectonics. Of course, the plate tectonic theory is the latest theory, and it explains most of the things to the best of the context. But it has its own criticisms also. One of the criticisms, I'm going to speak about the criticisms at some other point of time, next lecture probably. And next lecture, by next lecture, we should be moving into G suits finally. Okay, if you still don't have your credentials, get hold of them in a week's time as such. Okay, we are going to speak about the criticisms. One which I can prominently remember right away is that while it speaks about plate tectonics, speaks about plates, and initially they said that there are 6 major plates and 6 minor plates as such. It has been found that you're going to all the plates. If you call it as a plate, okay, you have your own dinner plate, isn't it? So if you move your plate this way, the whole one is going to move. The all in it is going to move like this. If you move it this way, the whole thing moves together. But it has been seen with very precise instruments which are being placed in different corners of these plates as such that not the movement of these plates is not the same, which is indicating at the fact that every large plate in fact could be divided into smaller plates also, and we are at such a time that maybe these plates are not being separated from each other, but a few thousand years down the line, as we spoke about the fact that the Rift Valley of Africa, a few thousand years down the line, it will separate the main continent of Africa to, I would say, a satellite continent of Africa as such. There are other criticisms also, but I would stop here today. If you have any questions, you could just post them in the comment box. If you don't have any questions, I'll just wait for a few more seconds and before I close down the lecture as such. Okay, if you have any questions, please do type them. Feel free to type them in the chat box. If and of course, after finishing with the plate tectonic theory, we would go to a continent building theory, which is a bit different to these things in a sequence, and that is why I've planned to take it separately. The theory of isostasy as such. It's basically how the continents tend to balance themselves on a rotating Earth. It is more scientific and uses a lot of physics in that. We are not going to use any physics in that, let me tell you. But being students of science, let me share you that it includes a lot of scientific rules and laws as such. You can search for the term isostasy and what it means. It's, as I said, it's a balance on a moving surface because the Earth is rotating, isn't it? And while the Earth rotates, you'll see that it's going to create centripetal forces, more centrifugal forces. So obviously, continents and pieces of different parts of the continents of different densities need to balance themselves. This balance is basically called as isostasy. How people arrived at this theory of isostasy is a very interesting theory, and in fact, it required mathematicians to say finalize this particular theory as such. It's very interesting. You can go ahead and read it as such. I'll try to explain it when we meet for our next lecture. That's the next Monday. And if you don't have any questions, let us call it a day. Thank you for being with me, and I'm ending my broadcast right now.